John, how can you always have the right TV for the right application without carrying hundreds of valves on your truck?
You can carry the hundreds of valves on a trailer behind your truck.
That's too funny. That would work, but how are you going to do that? Maybe there's an easier way.
You can use Sporland's interchangeable cartridge style Type Q and Type BQ TEVs. Type Q is a conventional design and Type BQ is a balanced port TEV.
Well, come on. I need easy. How easy is it?
Easy as 1, 2, 3.
And it serves thousands of unique applications. So what's the process? How do I put this together?
First, you select the thermostatic element assembly. Then you select the body that you need. Then you select the right size cartridge for the application to get the proper capacity TEV for your application. And then I guess it should also be said you want to actually assemble those into a single valve.
That'd probably be a good idea.
Indeed.
These easy to select and assemble valves mean you're always carrying the right valve for the right job then. If folks want to learn more, what do they do?
You can go to sporland.com and find more information on the Type Q and BQ thermostatic expansion valves.
I guess that's Jim and John for Sporland signing off.
We've all been there, in the middle of a job, everything going smoothly, until boom, you're missing a part. United Refrigeration is your one-stop shop for all your refrigeration needs. Use your computer or smartphone to go to www.uri.com at any time of the day or night to check stock on your favorite brands, such as Copeland, Sporland, Carlisle Compressors, Danfoss, Emerson CPC boards and sensors, Carrel, Hussmann parts, and K2Therm. United Refrigeration Inc. is home to these brands and many more. Looking for information on refrigerant conversions or refrigerant banking? Quick access links on the homepage can get you to the information you need. All approved accounts are able to see live to-the-minute inventory and pricing. Product not in stock at your local branch? No problem. Use the Nearby Stock feature to find a local branch that does have what you need. Are you looking for a branch address, phone number, or after-hours number? That's all available as well. Just click on the branch locator and search for your local branch. Have a model number and looking for a replacement part? www.uri.com/ARP has a vast list of quick pick replacement parts. Just search for the model number of the equipment you're working on and click the Replacement Parts tab. If you don't have an account, click the Register button and we'll have you online in no time. With more than 400 locations in North America, each United Refrigeration branch is fully stocked for immediate pickup. Our branch employees have in-depth technical knowledge, so we can help you get what you need when you need it. Visit your local store or www.uri.com/ARP today. United Refrigeration Inc. has all your solutions down cold.
What's going on, everybody? Welcome to Advanced Refrigeration Podcast. You're here with your host, Brett Wetzel and Kevin Compass. You look angry. Why are you so angry?
Well, it's been a rough beginning of the week already. I'm a little bit happier now that I got a shower.
Well, wait. What do you mean? What do you mean you got a shower? Tell me.
That I just took a shower. And I'm not covered head to toe in oil anymore. Since I've been covered head to toe in 100 weight screw oil since 7 o'clock this morning.
Oh, and screw oil is like molasses. How did that go? What happened?
Oh, well, I went to go change an oil filter on a rack that got changed yesterday and blew out already.
Holy shit.
It wouldn't drain the oil out the bottom because the packed angle valve in the bottom was all plugged up. So I already knew where this was going. I already, kind of just, bit the bullet and accepted my fate that I was going to take an oil bath today at some point. And I started loosening up the cartridge, the screw compressor cartridge for the main oil filter, and ended up shutting the rack down. I'm like, you know what? Let's just shut the rack down. These ball valves are 20 years old. They probably are leaking through a little bit. So shut the rack down and I, got it about halfway off and I start, rocking it back and forth a little bit, get it to start leaking out oil. It stops about 5 minutes after doing that. I loosen up a little bit more oil comes out. So I'm like, you know what? I'll give it 10 minutes. I rock it back and forth, nothing comes out. Well, evidently somebody double O-ring this thing. And the other O-ring must have slid down and seated somehow.
Mm-hmm.
And the guy that was working with me, the other construction guy, I'm like, well, let's just go another quarter inch or quarter turn and we'll see if any more comes out. And mind you, this has been like going on for like 20 minutes. I'm waiting. I was being like super cautious because I've already been through this before. And this thing,
hold on. Same store or different store?
Same style stores, same style racks. Like these Carlisle oil filters are notorious for you're getting a bath. Because what happens is there's a packed angle valve on the bottom of them, and when the filter explodes, it pushes the steel down of the filter all the way down against the bottom of the housing. So then it blocks the flow for the packed angle valve, rendering it pretty much useless.
So wait a minute. So on the Carlisles they have an internal oil filter, right?
Yeah.
Where like no, it's external.
It's external.
Okay, so
True.
same. There are some compressors that have
like carrier screws, like for like 06Ts, which are like mostly what we use, like in refrigeration. Those all have external oil filters.
Okay.
So these have like the green cartridge external oil filters. They're just like hydraulic filters.
Gotcha.
Basically. So, I mean, what happens when the filter explodes is it pushes down to the bottom of the housing, and it blocks the housing.
Gotcha.
And usually it's a like tight seal. You may get a little bit out of the packed angle, but I had it wide open and there wasn't anything coming out. So I already knew this was going to end bad. So I start, I throw a towel across my lap and I put my hat down as far as I can go on my face and I start rocking the filter back and forth. I'm like, all right, let's go another quarter turn and we'll see if anything comes out. I get like an eighth of a turn in. It's probably still 2 more threads left. Boom! Filter blows. The housing just blows straight out, straight down, hits me in the hand, and just bounces off the concrete below the rack and just goes shooting back up the other way.
A little bit of pressure behind it?
Yeah, straight discharge pressure.
That's awesome.
And then like the whole room just goes white. And I look down and I am talking like I caught the whole brunt of it. Like there is like a silhouette behind me of just like my shape of my body. And like I am just drenched in oil.
It's like the Wile E. Coyote in the Looney Tunes where he runs to the wall and there's that outline of him. Basically, that's an outline of Kevin on the side of the fucking building now. Yeah.
So it's like, and I'm looking and this filter is just mushroomed. Like it wasn't as bad as the first one I sent you. Like that I walked in the rag around. I'm like, oh shit, that filter looks bad. I look at it, it's just pure metal. Like just pure metal inside the filter.
So wait, the one you sent me wasn't the one that was totally grenaded?
Remember the one I sent you yesterday?
Yes.
That was the first filter that was in there.
Okay, so the one you sent me today
was the one that they got changed yesterday.
Damn. Low temp?
Medium temp. So what ended up happening is number 4 compressor, somebody wrote it up that it tripped the breaker and it needed a contactor, and they also had to change the oil filters. Well, plain and simple right there. If you get a screw compressor on a screw rack that has a tripped breaker and you have plugged oil filters, it's probably not the contactor. It is probably ate itself.
Yeah, so, usually if you don't have the right oil flow, the bearings will take a crap for the thrust bearings, and then you'll get or electrical short in the back.
I'm doing a startup here, and I'm like, we can't get the box down to temp. The rack's overloaded, so like I'm going to fire up number 4. I'm going to figure out what's wrong. The service department's got a contactor coming. There's supposed to be a service guy coming there. I'm like, well, this doesn't seem right. I turn on number 4 compressor, and I swear to God, I have never heard a compressor make such a horrendous noise. Like, it sounded like rotor on rotor.
Oh.
Like, it ran for like 45 seconds. The amp draw went from 50 amps to 60 amps to 70 amps to 90 amps before I got the switch off. Like, it was pure metal on metal. It plugged an oil filter in less than a minute.
So if you guys aren't aware, screw compressors have a fairly tight clearance on the male to female rotors. The compression is actually completed by the copious amounts of oil that it's sucking on in. So if you don't have that oil, then that means, you have a lot of friction, a little potential metal on metal, and no dice, just not good. So was the rack oil dirty prior to this, or like what, because now you're seeing it through the rest of the system, so it obviously couldn't have pushed all that shit through already.
It's a 21-year-old beat. I'm talking like beat is saying nice rack that was glycol originally, which is now like 75% DX. It's on its like 17th remodel. There isn't a single ball valve that holds on this thing. Like, it's just the rack is just like it's done. It just wants to die. Like, it's
and didn't you just say you're doing a startup on it?
Yeah, it just they just added like a ton load. So basically, what I mean, the oil's trashed. Like, but usually with the screws, so you start up with cleanup procedure. Generally, the oil filters catch everything in those things, because they're moving so much oil through those things. The oil filters catch everything. So what we're doing is every morning, service guy gets there and changes the filters every morning.
Are you sure? So here's the thing. So now I'm questioning whether the other service technician actually did it, and only because
it's starting today. Like today, we started.
Oh, yeah. Oh, okay. Because when you said that the one that they installed the day before was already mushroomed, I was like, wow, that's really, really quick for for an oil filter. I don't know.
It made it one day and mushroomed. Like they usually make it about when we lose a compressor like that, it's a day and a half. Usually you end up blowing another filter. So the only nice thing here is if somebody wasn't stupid and left the whole filters on, you're supposed to have one filter on, one filter off. So there's two filters. You have a spare and you have a primary. Mm-hmm. So that way, when one does plug, if it plugs in the middle of the night, or if it plugs and you could turn on the other one, valve off that one, change it, and then go on your way. It isn't going to take the whole rack down.
Are you saying have because each compressor has its own filter? So
nope. It's two filters off the main oil line. That's it.
Oh shit.
Yep.
Okay. All right. So they're in parallel with ball valves before and after. So you can just run one for the whole entire system.
Correct.
If you need to, you could bypass it. Okay. Because I'm envisioning most of the racks I've seen are hill racks.
These are all hill racks. Yep.
Okay. Well, typically when they have the Bitzers, every single one has their own individual. Even the Hussmann screw racks I've seen, each compressor typically has
that's a Bitzer thing. So Bitzers use those individuals, and a lot of times they have those oil flow sensors built into the housing.
Yeah.
And it goes back to that the vape cool like Econo ESC 2000 or
200.
200, yeah. It goes back to that controller. So that's how they're doing their oil flow. Carlisle actually has a pressure switch that goes, so they use like a Johnson Controls pen mechanical pressure switch that is looking at discharge pressure versus oil pressure.
Gotcha.
So,
Greg from Bitzer, I was talking to him because we had a store that had two ERC controllers, the 201s or whatever, that were just they were intermittently just losing. It was losing an input occasionally, and it would just fail. Like we did everything. We even jumped it out, just to see if it would still fail, and it did. So the input was actually bad. So we were in the process of quoting to get two replacements, because now they're using the what's the controller they're using for the other Bitzers now with the not the Vari Speed, the Damn it! What's that controller that you have to hook? You have to hook up with the same software that you hook up for the vari-speed, and it's basically a cross-cut conversion of, it'll convert straight over. It's just the controller that Bitzer uses for their digital unloaders. You know how they used to use the
Oh,
Siemens?
damn it! I just put one of these in. It's actually really great. I forget what it's called.
I'm having a brain fart as well.
Yeah, but they use those for the screws too now.
Yes. Well, that's what I was saying. I was saying that they're basically taking that one. There we go. Hold on. I just got it. I just found it. The ESC to the SEI1.
Yeah, it's got some like generic name like compressor board or. But
I really don't think
they use those Carlisle on some of the newer stuff. So like these ones are old enough where they had the old school Carlisle modules where they just have discharge temp and the oil. Some of the newer Carlisle modules, they'll actually take and they have 2 transistors, and that's how they're measuring their oil differential. But these are 20-year-old screws. So we scrambled number 4.
That's not the one.
That's the one.
Okay, yeah, that's the SE1, SEI1.
I think they call it like something else though.
It's just the number on it. Don't yell at me.
So like we scrambled number 4 screw. So we're basically screwed on that. Well, yesterday number 3 kept tripping on oil. So it tripped on oil like 3 or 4 times. I'm like, with a million other things going on, I didn't have time to deal with it. So service was supposed to come out, look at it, and dig into it, see if we needed oil switch or what, because it would time out for like a minute and it would shut off. So I'm like, okay, well, whatever. So I go about my day, and we're starting up this freezer now. And we go to turn the freezer on, and this is a big freezer. It's got 7 coils in it. Massive freezer. So they took a bunch of load off this rack, took a bunch of coffins off, and they're putting this like big OGP pickup. So I go to start the freezer up. I'm like, what the hell's going on here? Like the rack don't sound right. And I look at the controller. It's like 29 pounds of suction pressure. Okay. It's 507. So it's like 12 pounds, 13 pounds over set point. And the freezer's already at stage down temp of 35, and it shouldn't have a ton of load. Looking around, like, okay, all the compressors are running. Why is number 1 variable speed at 30 hertz constantly, all the time? So I'm looking around like, oh, somebody unwired the inverter signal.
Oh, so it was just going minimum 30, and that's it?
So I'm like, this is weird. So I wire up the inverter, and all of a sudden it goes, it shuts off.
All right, hold on. Let me take a guess. So they unwired the inverter so it wouldn't use as much oil, and because it had oil issues.
Nope, this is a different rack. This is a low temp rack now.
All right, go ahead.
Well, I'm like, what the hell was that? I'm looking around, no schematic. 20-plus-year-old rack. I'm like, son of a bitch. It's all hacked up and been rewired. I'm like, okay, so I finally figured out it's missing the forward run. I find the relay. Okay, trace it back. It's tripped on high pressure. Okay.
Oh.
I push the high pressure switch. Ramps up, gets to 30 hertz, and then all of a sudden it goes, ramps up, gets to 60 hertz. I hear that it sounds like shit. This doesn't sound right. It's pulling like 60 amps. All of a sudden, here, shuts down again. What the push it again. Starts back up. It runs. Well, running it for a little bit to help drop the suction pressure off, so some of the load came off.
Yeah.
Like, whenever it gets above 250, that it trips on high head. Like,
but
okay. So like,
what's the control set for? So, obviously it's gonna be like 350 or something like that. Yeah.
Yeah. So I'm like, okay, what's going on here? Like, you don't sound right. You could hear it. It's like you got a high pitched like noise going. So I'm like, okay. I started looking through it, and I'm like, oh no. I was like, this. I already know what's wrong. We've had this problem with these service valves before, like different stores. Mm-hmm. I throw a gauge on the compressor. I throw a gauge on the discharge header. So we have compressor, service valve, muffler, discharge header.
Gotcha.
Start the compressor up. Watching it. It's got like a 30-pound drop, 20-pound drop, 30-pound drop. Gets 60 hertz. It's 130 pounds.
Damn.
Compressor's running 370 pounds before it kicks out.
So it's either the muffler or the service valve, right?
Well, yeah. Well, Carlisle had a problem with these service valves they had. And what would happen is the discharge pucks that shut the service valve off break off and get lodged in the discharge hole. They break off the stem. Instead of being back, now they're stuck in the hole. What usually happens is they usually just trip on high head every single time. You go to start the compressor, instantly high heads. This one was stuck like 3/4 of the way. So it was whenever the volume would increase in a discharge, it was acting like a slide valve almost. It was blocking the discharge rotor, the outlet, and it was backing gas up in the compressor and then eventually caused it to high head.
Sweet.
So, okay, so, not that big of a deal. Well, shit, we got to pump down the whole rack and we got to bust the discharge service valve loose on the compressor that's 15 years old with no gaskets.
Oh, no.
So luckily we found this compressor had steel gaskets. Thank God. We cleaned it up, nylogged it up, put it back in the exact way we took it out.
Wait a minute. I have a question here. So you do not have a gasket cutter kit?
I don't. I did it one time. I just don't.
Okay. I'm just curious. I'd to think that would be something that you would have. Like to make your own, just because you're involved with so many, startups and stuff, I'd to think that you would potentially have that.
To be honest, like Carlisle gaskets are hit or miss. Like Copeland gaskets, I have a ton. Bitzer gaskets, I have a ton. I even have Bitzer screw gaskets. But Carlisle gaskets, they never send out extras. So we split this thing apart and we got to pull it back because there's no rotor lock on it. You ain't moving the compressor. So we got to pull this thing back. So there's two guys pulling back while I'm in there with a control screwdriver trying to break this puck out of this pipe. It's basically stuck in the pipe at this point. So we finally get it dislodged, get it back together, and start it back on. Thing runs beautiful. It's pulling suction set point. Rack went from 100% capacity down to like 75% capacity. It's running good. No more problems. So I look over and I'm like, well, it's already three guys up here, or two other guys up here and me, and everything's already up here. I go, let's go look at number 3 compressor. So the way that Carlisle does their oil pressure is it's discharge versus oil. Okay. If you have a blockage on your discharge pressure, it's going to make it look like you have no oil pressure, net oil pressure. So I'm like, maybe that switch isn't bad. So we get on top of the rack because in order to get to the discharge service valve, you have to climb over the top of this rack and go down the back side of it because it's buried behind a chiller. So you have to get a 6-foot ladder. You have to climb over all the piping that has been run in this room. And then you have to drop back down the other side to get to the discharge service valves. We throw another gauge on there, except this time now, this compressor doesn't trip on oil. It just trips on high head. Instantly. So I'm like, shit. So we go to take this one down. Well, this one turned into a disaster because this rack, it's had lines added. There's stuff all over. There's ball valves buried. So we start shutting off everything. Well, 2 other compressors already have the pucks pulled out of them. So we can't shut those off. So we shut the suctions. 2 other compressors have ball valves. So we shut the ball valve. Those ones, thank God, have ball valves. So it's still not holding. Can't get the discharge down below 40 pounds. So we start shutting off all the suction lines. Still can't get it. Shut down all the discharge lines we can find. Still can't get it. Shut down all the subcooler lines, economizer lines, oil lines, everything on every single compressor. Finally, we get it down to like 10 pounds. And it won't go any lower. Something's bleeding through, don't know where. Impossible to find at this point.
Wait a minute, 10 pounds in holding or 10 pounds while you have a vacuum pump on it?
No, 10 pounds while it's coming out of the valve.
That's
so, yeah. So at this point, we're just like, okay, we have to make a go at this. They're running on 2 small pumps and they're like 4 pounds over suction pressure. And I'm about to bring on 65 horsepower of load. So both compressors that were down, the one that was dead and the one that was down, were both 50 horses.
Gotcha.
So we're down 100 horsepower. This is a massive rack, by the way. Massive. I think it's 5.
Damn.
350s, and then a 65 and a 25.
So you have a lot of volume and gas too. You probably have like a 3 1/8 fucking discharge line.
4-inch. Yeah, it's massive. So we're just at this point we're committed. It's like, okay, so we just pull the thing out and it's just blowing. This one unfortunately was like jammed in there like by Thor. So I'm in there with a control screwdriver and basically using it as a punch to punch this thing out. Finally get it broken out of the pipe and back together. And then I dropped the gasket into no man's land.
Well, if you couldn't get it out, that just means you weren't worthy.
Yeah, well, we got it out. Well, then we found I dropped the gasket into no man's land. That, thank God, there's only been like, I don't know, probably 15 screws replaced here in the 20 years. So we're looking through boxes. We're tossing stuff all over this rack room. Finally, we find a gasket and get this thing back together. Well, now the service valves are like leaking like a sieve because they're 20 years old and there's no backing in them anymore because you don't have the puck in there.
No, I get it.
And telltale sign before this, these service valves got rid up on a leak repair because they were leaking because the pucks broke off.
Guys, here's an easy one. This is the second question for September. This is to enter the win the Field Piece scale that came out this month. What's the glide on the refrigerant 448A? Let me know. Email your answer to arpgiveaways@gmail.com and let me know. Hello guys, this episode is brought to you by Field Piece. The tough wireless vacuum gauge MG44 from Field Piece is engineered to give you the reliable reading you need and the ease that you want. Confidently measure vacuums with a reliable leak-proof seal. The MG44 can be used with the JobLink system app from up to 1,000 feet away. This easy-to-read backlit LCD offers a graphical representation of the vacuum progress, even in low light or at odd angles. Visit www.fieldpiece.com for information or follow us on social media at Fieldpiece Products. Thanks again and enjoy the episode. Hello guys, this episode is brought to you by Field Piece. Field Piece's next generation of vacuum pumps will cut down on evacuation time and make oil changes on the fly a breeze. They are lightweight, durable, and feature 4 inline ports plus a large oil reservoir. Get pumped about these 3 new Field Piece vacuum pumps available at distributors now. Learn more at fieldpiece.com or follow us on social media at Fieldpiece Products. Thanks again, and thanks for listening. Thanks, guys, and let's get the episode. Hey guys, today's episode is sponsored by Westermeyer Industries Serviceable Oil Floats. Many oil separators contain an oil float to effectively meter separated oil back to the compressors. Westermeyer Industries has taken this concept and perfected it. with their new line of serviceable oil floats. These floats feature an improved design with fewer components, allowing for greater manufacturer consistency and up to 20% increased oil flow versus their legacy models. These floats also feature an integrated magnet to shield the oil path from debris and have been field proven in supermarket applications. Westermeyer Industries offer replacement oil floats not only for their own separators, but also cross-compatible models for our competitor oil separators as well. You can find out more about the Westermeyer Industries serviceable oil floats by visiting westermeyerind.com/floats. Once again, that's westermeyerind.com/float. Let's get on with the episode. I got you.
So that was the first sign that these things were broken, and the 6 other service calls for oil failures.
Well, you know what? Now that so is this the same rack that had the really, really shitty oil that was eating up the, that was blocking up everything?
Yep.
So,
They-
I mean, that kind of makes sense because if
They
you're
both,
running,
they both had a block. Both racks had a puck that was broke off.
okay, well,
Both
that's,
had intermediate temp.
that's what I'm saying. So, like, you know, basically you're running a really, really high discharge pressure, extremely amount of heat in that one compressor, and it's just boiling that fucking oil.
Yep. I mean, it'd be more of a problem if it didn't have a giant oil cooler, but
It does or does not?
it does have an oil cooler. So it ends up using the glycol for an oil cooler.
Both medium and low temp?
Yeah. Low temp has a separate actual coil on the roof. So it has a actual like 2-fan bone unit on the roof that's cooling the oil down.
So with screws, it's incredibly important that you actually, you know, use some sort of cooling for the oil. Sometimes you'll see what Kevin was seeing. Sometimes you'll see, you know, it'll take a pass of the condenser, whether it be an evaporative condenser, an abatic condenser. You know, basically it'll run a loop through there for de-superheating. Sometimes what you'll even see is Bitzer has this thing called jet cool. It basically uses off of the drain leg. There is a vertical receiver. And basically what happens is this vertical receiver is before the main receiver. And so whatever liquid, it's basically a thermal siphon, because any liquid that's going to travel is going to travel to the bottom. Then basically what they're doing is taking that liquid that's sitting in the bottom of that thermal siphon, running it through a heat exchanger that's usually typically controlled by, it looks like a Parker A8 valve, you know, like a big body, but it doesn't have the adjustment stem at the bottom. It basically just has a solenoid on there. And usually they'll have a controller that pulses that to control a discharge temperature. So if you're trying to control, you know, 180 degree, you know, oil temperature and it's higher, you know, it'll start pulsing a little bit more. Then what happens is with the liquid that basically boils off, that refrigerant then is piped into a heat exchanger on the discharge line, and that actually goes back into the condenser so it can get recondensed. Doesn't need to get recompressed, but once it uses the energy from boiling off the refrigerant, it gets redistributed and goes back up into the discharge line, and like I said, goes in to get recondensed.
Yeah, so these racks are all economize vapor injected scrolls or screws. So they have the economizer in there, and that's really important. That's your cooling for those compressors. They have economized vapor injection, or like Brett was talking, they have that Bitzer uses that cool jet at times, or they use an economizer from a subcooler, or they also use Y10s usually to help cool them. But these are just economized injected because they have the oil coolers in them. They get away with that. But oil cooling with screws, like if the oil is like boiling hot, it's going to overheat your motors. It's going to overheat your rotors. It's going to dramatically decrease the life of the bearings in the compressor itself.
Well, let me ask you a question, because I'm just thinking about this logically. So if we had a compressor that was running a very high discharge temperature, wouldn't you would basically have less amperage, because typically they're using anywhere from 100 to 160 weight in those screws, in the rotary screws. And if you have an obscene amount of heat, basically it's going to thin down that oil to be even thinner, than what it is. And
Oh yeah.
you'd have lower amperage, yeah?
Well, you'd have lower amperage just for the fact that when you block the discharge of a screw, it's going to decrease the flow. So it's like blocking, like a slide valve blocking the rotors.
All right, yeah.
So that's why it reduces the flow. But at that point, that's not what caused the compressor to fail. The one that failed actually was a 2-year-old rebuild, which I'm surprised it even made it that far. It was not a genuine Carlisle OEM rebuild. It was
No, that's right.
it's from everybody's favorite compressor rebuilder, which I can't even believe they're rebuilding screws. But yeah, that thing, God only knows the tolerances on that thing, where it was probably put together by some 12-year-old kid. But yeah, that's why that one was toast. And who knows, once it gets running, I mean, it could have bad oil control. I mean, could have had low oil flow. That one's the farthest on the header, so it's getting oil last. So
See,
if it was plugged up, I would go ahead.
It sucks too, because you really can't tell like when the last one was redated, because when they rebuild those compressors, they pull the old model and serial number tag off there. So it's not like you can tell, oh yeah, this compressor that they rebuilt was from 2000 something.
Yeah, they slapped some more paint on there and called her. They slapped some paint on there, fixed the unloader valve that was probably bad at the beginning, and sent her right out the door. So after all that like mess, we I go back to my startup after I'm covered in oil, and we get these compressor pucks out. Yeah, there's no way to shut the discharge off, but in another month they're going to be all cut out and replaced anyway. I'm not messing with it. So
the valves.
Yeah, all the valves are getting changed. So part of a rack rebuild. So all the valves are getting changed. So I'm not messing with it. We pull the pucks out.
So explain to me why it would be more cost effective to replace all the ball valves than it would be to replace the rack. I never like.
Hey, I'm not the customer. Like,
No. I understand that. I'm just trying to
the amount
understand.
of money they've dumped into the store. Like, I cannot believe they didn't get new racks.
Wow.
Like, I don't know. Like it to the customer, it's obviously cost effective. I don't see how, because our labor is through the roof for all that stuff. I mean, you're talking, it takes a lot of time to do that, because I mean, we can only do so much at a time. We may get a couple handfuls done here and there, a couple handfuls. It also depends how much the store watches us. If a store's watching cases like crazy, I mean, yeah, we don't get very much done in a day. And if you get a store that, doesn't even notice the rack's down for 4 hours, and you get a lot done in a day.
Are you doing a gas conversion on it too?
God, no, thank God.
So they're keeping it 507?
No, somebody's doing 448. I'm not doing it.
I'm not being a part of that.
Oh, I want nothing to do with that. No, these racks are terrible. Like, they're old, and like they're stacked all weird, and it's going to be literally people climb. You're going to have to set up scaffolding. You're going to have to work off scaffolding.
I'm just wondering, like, if anyone that's pissed off with you can just be like, hey, I have an idea. Kevin said he wants to do the gas retrofit.
No, I'm not allowed to do those. Those are done by the service department.
Gotcha.
I don't do those unless we're changing the whole rack out, which makes sense. It's a lot easier to do a retrofit when you just change the whole rack out. Back when then obviously we go to the startup. Well, I go to start up these 7 brand new freezer coils. Every single coil is wired differently from the factory.
Sweet.
Not one coil was wired the same, and they all have these
the hanging evaporators. Yeah.
Yes, the hanging evaporators.
Okay.
So they all have these sweet new controllers in them. You need a 0 to 10 volt signal to modulate the fans.
Wait, what?
Yes, they have a modulating. If their evaporator fan motors modulate all the way down to 470 RPMs with a 0 to 10 volt signal.
Why?
And or you could have a Johnson Controls proportional controller in there that will take the temperature. When it gets within out of 5 degrees at a set point, it'll start ramping up the fans, because this is never going to cause any problems. And then the said manufacturer, like in this cabinet, there is a transformer, a control board, double the amount of wiring. And the control board for these fans is mounted 1.5 inches from the bottom of the pan, because this pan is never going to back up and ice up.
So that means every time you got a monkey with it, you end up having to disable the signal so the fan ramps up to 100%.
Well, these, like, the customer didn't even use them because they didn't even know they were there, because like they're not on the coil drawings anywhere. So nobody included this in any of the controls.
So because CPC store, right?
Yep.
Case controller controlled.
Nope. This is the box is just standard suction control.
Okay. All right.
But it's just TXVs and on and off.
All right. So then you'd have to run an analog output signal all the way over to the control. Are they like the MPass ones where you could basically, do they have their own 10 volt DC where you could just jump it out and just be 100% all the time?
Thank God somebody in their infinite wisdom, 0 volts is full run.
Sweet.
Okay, but here's the problem. If the board is not there, it will not run the fans. So if the board goes bad, if there's no 24 volts at the board, it will not run the fan motors.
Wait, what kind of board are we talking?
It's some like little tiny like board for these motors. These motors, like I'm looking at them. Okay, you got the standard 2-wire plug that you have in all about coils running through there, and then there's like two speed wire reference wires coming out. Like, oh my God, this is gonna get so messed up. This is gonna rub through. Nobody's gonna be able to figure this out. Like, this is a nightmare.
I have a question. How long do you think it before someone's like, yeah, it's too complicated, I'm just gonna rewire it and put 120, 240, whatever in there? Oh God,
like as soon as it's out of warranty, I don't blame them. Like okay, I'm cool with ECM motors. That's fine. If you want to throw 2-speed motors in there, that's fine too. I get it, but there is no need for that in a 3 and 4 fan medium profile coil. That's insane.
It's comparable to turning off LEDs. You know what I mean? Like
really saving?
Like when they put the LEDs in, and then they were like, well, we're going to put them on motion sensors so it'll save energy. When the energy that it would be saving is getting wasted from the cycle time that you're turning these things off and on. We've had this discussion before. I understand everyone wants energy efficiency, but how much energy efficiency is too much energy efficiency? Like where if everything in lab is not fucking perfect, it's just going to tell you to go screw yourself, so to speak.
Well, that's my thing. Like, I'm all about energy efficiency and improving stuff and all that stuff. But like, holy cow, man, like that's insane.
No, I don't get it. Like and then it's 20 times more difficult for anyone to usually diagnose, because they're going through the normal shit that they're going through, and then totally forgetting that, oh, well, these now have either a dual speed motor. I mean, how many times have you gotten a call on the phone and you talk to someone and you're like, hey, does it have a 2-speed motor? Like, no. And then you get up there and sure as shit, it has a 2-speed motor and it's running low speed.
Yeah, it happens a bunch. And like, those motors are extremely hard to get. They aren't just sitting on a shelf, and they're like $600 for a 2-speed. How much is this motor? $900? And you got to go to the OEM to get it? Like, it's insane. Like, you're talking an ECM motor you can get for like $150 that slaps in there and saves the same amount of energy.
So in this instance, are they using one proportional control for every single evaporator, or are they using one proportional control per evaporator?
I'm not even using any of it.
I'm saying if it was wired in.
It could be both. Okay. It could be either way. Like, I'm looking at this thing, I'm like, oh man, this is like, I'm reading the manual, I'm like, this is making my head hurt.
Send it over. I want to take a peek.
Yeah, I'll take a picture of it tomorrow. Like it's but it's not just it's like Bone, Heatcraft, like everybody's doing it. They all have
Really?
these zero. Yeah, it's just
I'd really seriously like to know like what this has to be a UL thing. It has to be because I mean, how much more energy efficiency can you
DOE
really
thing.
get? What?
It's a DOE thing.
Yeah. Okay. Well,
Yeah, it's
that's
100.
which is gonna affect the UL rating. Yes, because the same reason why we have to use the AWEF condensing units and shit. Department of Energy.
So I mean, I'm not really sure. Like my head just hurts even thinking about all that.
I'm
So we get
wondering.
all those rewired.
I'm wondering if they're actually if the Department of Energy is figuring in how many times it's going to take to get it fixed right, and all the gas that's going to get burnt with all this super duper energy efficiency stuff. Just a thought.
I mean, maybe. Like I don't know. Like the more complicated they make this, it's not helping the situation.
No, not at
Then
all.
we go to fire up the other box, and the EMS contractor completely screwed me the day before on that, and I spent like 7 hours fixing their boo boos with that. So can't even run the other box right now because I'm still down a 50 horse compressor. But it's pretty cool. Like this place is all robots. Like the entire OGP is robots.
Really?
Yeah. So like this cooler is, I don't know, 35 foot tall by 15 foot wide by 100 foot long.
Does it have little robots that travel on the side of the racking and go up and pick up the box and bring it down?
Yep.
Yeah, that's the new go-to. One of the places I went down in Georgia, I went down to a warehouse, and that was their go-to. That's all these on cats that are working in there aren't going to be working on there that long because they're basically stowing everything. They'll put it into another bin. It comes out because I remember talking about someone when they engineered it, they had to figure out the actual heat loss and heat gain of the containers that were coming in. Because I mean, that's not something when they're making plastic bins that no one's saying, hey, would you figure out the heat loss and heat gain for that particular item? Because we need to know, because we need to be able to calculate how many BTUs we need per the amount of quantity of plastic bins that you're shoving in there.
Yeah, like this is insane. There's probably like 14 nerds sitting at this table, like straight up computer nerds, just sitting there.
German company.
Like it's a bunch of like college kids.
No, I get it. But what I'm saying is, I forget the name of the company that was there at this other place, where basically it was there was like 2 or 3 people working on it, programming it, because they were having problems programming it because the humidity was too high in the box.
Yeah, they were complaining about that yesterday. I'm like, well, that ain't gonna change until this gets fixed. But I mean, no, this is all U.S. based stuff. Like when I looked up, I don't remember what the name was, but when I looked up the name, it was all U.S. based. And it's a bunch of like straight up like 20-year-old college kids here. Like it's cool. I mean, but when it breaks, till those robots become self-aware,
Skynet comes alive.
I mean, this thing is going to be literally 100% unserviceable. Like if you have to service this thing, you have to shut down the whole robotic system.
Yep. Yeah, we there was a kill switch on the outside of the box that went to their system. So there was e-stops all over the place. So you don't get crushed. I mean, because those robots actually go pretty damn fast in the conveyor system. So there was a kill switch on the outside box that as soon as you would open up that door, it basically put it in standby mode, and because then it would give you enough time to get to the secondary door, so it wouldn't be running by the time that you did get to that secondary door.
Oh, so the robots will kill you until they literally are made self-aware. Then they're coming at you.
As long as you don't look like a head of cabbage or something, I guess. I don't know.
I don't know. Like to me, I think the whole thing's kind of like, it's cool, but like at the same time, like I'm looking at all this fiber optic cable and everything else. I'm like,
I'm gonna go to automation. That'll be fun. I'll fix the the hamburger flippers.
Yeah, this startup's been kind of a nightmare. It's just been like one thing after another, and of course like it's split up into like 3 different contractors. So this contractor's doing this contractor's doing that, and then we're only doing the refrigeration. So it's like now I get to play the argue game of the finger pointing game, and it's like ultimately it's always the refrigeration guy's job to fix everybody else's screw ups.
Well, fortunately enough, it's on a rack, So it's not like it's on, like controlling any of that shit on a self-contained unit.
A
is
single unit
gonna-
would be a disaster. It would be
What?
an absolute disaster on a single unit.
Unless it was loaded up, with like hot gas bypass valve, desuperheating.
Yeah, but they don't seem to ever put that in until they. Plus, you couldn't put any single units in this place because you literally can't put anything on the ground because they'll steal it.
It's in the middle of Chicago.
It's on like the edge of Chicago, like to where like one side's like super yuppie, and the other side you're gonna get shot.
So I was on a side note. I was looking for real estate this week here in Dallas. And while I was driving through, we get to where we're going to look at this building. And the realtor's like, he's like, yeah, I was driving through here with like on the way over here. And he's like, I don't know if I'd be reluctant to be here because I don't think your catalytic converters would stay that often. I think they would probably go. I was like, yeah, I know. I saw the whole thing go down with the two guys that were hanging out together. It was the one building we looked at was in a real shit neighborhood.
It's bad.
Well, and how tall? Well, I mean, the roof's tall in this building too, yeah.
Yeah, it's got to be like 40 foot.
So this is a grocery store that's actually doing for the OGP, like where people buy, want to get their groceries. It's all automated for all the shit that's in there. Then,
Yeah,
but it's a regular conventional grocery store.
no, so like all right, half of it. They took a store. They took a store and cut it in half. And then they made half of it this giant online grocery, and the rest of it's still the grocery stores. I mean, it's a massive building. Like it was too big.
Yeah, some of the supermarkets that are big here in Texas, like the new ones that are getting put up by my house, are 111,000 square foot. It's comparable to, like, I don't know if you've ever worked on the East Coast, well, for Wegmans. It's like something like the size of that.
Oh yeah, like no, everything up by us is being small.
Gotcha.
I mean, like Aldi size, but bigger. But I don't know. It's been an interesting day today. Like it's been an interesting week. Like it's been kind of fucked up, but it'll get better until I get sprayed with oil again tomorrow.
Didn't you have off Monday?
Yeah, I did. When I was camping, and it was nice.
Yeah, well, okay. So it's now today's Wednesday, right? Yeah.
Yeah.
So you worked 2 days and got covered in oil both days.
Yeah.
That's awesome. Hey, make it a hat trick. 3 for 3.
Yeah, yeah, I don't know. But yeah, those Carlisle screws, that puck thing, I mean, I've seen it happen like 5 or 6 times now.
Yeah.
Super, super fucked up guy. It'll mess with guys. Like if you get that high discharge pressure, and like same thing with oil failures. Now with repeated oil failures, like you got to throw your gauge on there and check that discharge puck because it'll sneak up on you. But Carlisle switched to a redesigned service valve.
What makes that one different?
It's just, I think it's beefed up. It's weird. The one I sent you, the one broke the stem clean off, and the other one broke the C-clip out.
Yeah. So when you sent me that first one, I actually at first glance, I thought it was a solenoid innard.
Yeah, like no, it's a puck.
Yeah, I know that now. But it legitimately looked like the middle of a Sporlan solenoid. Oh, there's so much oil all over the place.
Yeah.
That's amazing.
Yeah, it was bad. Like, dude, it was in that picture you seen with the oil was after I like already sprayed like 2 cans of brake cleaner to try to like minimize. Like I was just like double fisting the brake cleaner, just like trying to clean off some of the 25-year-old Armaflex that was already covered in glycol and brake cleaner and oil. Like, I mean, it was just bad. Like it was the sound of it going off, like it sounded like somebody shot an RPG at me. Duck and cover.
Get to the chopper.
My entire beard was just full of oil. Yeah, it was bad. Oh, on a side note.
Yeah.
So I was looking through some of these, some of the prints, and then like the one walk-in, we're talking about the speed controls. So I have low profile coils than the other.
Cool.
Now they are talking, it shows on the print to take the speed reference for those low profile coils back to each XM controller.
Oh, there's no analog output on there.
Correct.
Oh, and I don't
There,
think there's not a
so
configurable input
there,
either.
so what they show is the analog. They show it going to the pulp or the anti sweat. I don't think it's gonna work. There's no way to configure it.
That's what I was thinking. Like it's not like some case controllers you can they'll have configurable outputs. You know what I mean, where you can change it to whatever. But I didn't think. I don't want to make a liar of me now.
Yeah, I tried today to look for it. Like, there's nothing to configure to because it's all canned.
Yeah.
I even tried looking in man, what the hell? Well, Wizmate. You can't even. It's not even an option in Wizmate.
Oh, if it's
so,
not in there, you're screwed.
So the other thing I wanted to bring up, which is another good XM thing. So okay, EMS contractor having issues. Can't get these transistors to read. I don't want to go too far into it because I don't want to throw anybody under the bus because I'll get an email. Okay, these transistors were reading 165 pounds. Okay, on a bunch of them. So what ended up happening is, if a transducer is not, if it's not seeing it, if it's not properly, if the controller is not properly commissioned, so meaning you didn't push the program from the E2 back to this XM controller on initial startup and then programming, for some reason it defaults the input to some random thing for probe 5, which is a transducer, and it shorts the signal. I don't know if it sets it up for 4 to 20 milliamps or what, but it drags down the signal. Okay, when it does this, it reads the max operating pressure value. So if the max operating pressure, meaning like the max you could let the pressure go to, is 165, it will read that value all the time until it is commissioned. So as soon as I was looking at these, as soon as I started pushing the programs back to them, I would have, from the white wire for your signal to black, I would have no voltage, 0 volts. If I pulled the white wire off and went to black and just had the white wire off the controller, I would have 1.8 volts, which is exactly what it should have had.
Yeah.
As soon as I pushed the program back down to these, they all started working. And I had the 1.8 volts that I should have had on the white wire for the transducer for the PB5.
Okay, so it wasn't configured when it first got started up.
Yes, but I still don't understand why it would drag down the DC voltage if it's not configured. It would drag down the transistor voltage to 0.
That would have to be a hardware thing, because if it's see, I forget what the options are. Like, I'd have to break out my
20 milliamp, or it's a CPC transistor.
That's why then, you're basically shorting it out. You're not getting that, you're just running full on power right through it.
It must auto default to 4 to 20 milliamp.
That's what I'm thinking.
That's the only thing I could think of, because it was dragging it down, and like these guys were having trouble figuring it out. So like, I go over there and I'm looking through it. And I'm like, we changed the cable, and I'm over here and I'm like, okay, we have it if I disconnect the cable, I got it. I'm like, okay, this is weird. So I start, tracing it back, and I pull the white wire off the controller, and I throw my meter on there, and I go to black, and I'm like, okay, I have the power. Put it back on there, no power.
So it was all because it wasn't configured for the CPC sensor then.
And it wasn't. They never pushed the program originally when they programmed it.
Oh no.
Which is a weird one. I've never seen these XMs do that.
Well, I mean, because you're typically programming everything and then pushing it, right?
Yeah, I mean, it's fucked up. Like, it was bad. I was scratching my head for a good 3 hours after, on top of all the other issues, and trying to run around and figure this stuff out. And yeah, this was a rough. To be honest, like the last 10 startups have been absolutely rough.
Is it because of the supply chain shit?
Oh yeah, it's gotten way worse. It's just, everything is just halfway put together, missing IOU tags. All these people are getting people from temp agencies to put this stuff together, and it's just horrendous. We had coils you couldn't even get transducers on. Like you physically could not fit the transducer where they put the packed angle valve.
I've seen a bunch of pictures just today.
I can't even tell you the amount of coils, and it's everybody where we've had to move all these transducers because you cannot get the transducer pack angle valves because you can't get them on.
There was a picture of someone took the equalizer line from the suction and brazed it into what would have been where you would screw the one side of the transducer in.
Yep.
Which I thought was kind of creative. Never seen that before.
It's getting bad out there. Halfway put together equipment is out of control.
You're killing me, Smalls.
All right, well, let's end it for tonight because I'm exhausted. Thanks for listening, guys.